Okay, so here's an update. I am taking my breadboard prototype and making it something that will fit in a coach or caboose or anything that you want to add lighting or be able to turn something on and off using track power. So here is the bridge rectifier, here's the capacitor, the buck converter, and the Hall effect latching switch. So right now I have the capacitor looped through the holes on the buck converter, and what'll happen here is it's probably quite hard to see, but I'll make sure that the negative is attached to the negative of the capacitor, and the positive is to the positive from the bridge rectifier to the capacitor, and solder that connection. And these will be coming from track power, and polarity doesn't matter, and it could be AC or DC, doesn't matter. The bridge rectifier will be set to 10 volts ish, and then the Hall effect switch I'll wire in here, and of course this will go to the negative to the light, and that will go to the positive. And yeah, then the switch is ready to go, and it should be reasonably small to conceal, like on the ceiling of the coach, or hidden between, if there's a dinette area that doesn't have any windows or something like that, we could easily hide it somewhere. So yeah, its total length is going to be approximately just over 2 inches, and leaving the leads on the Hall effect will allow it to bend to get closer to an area where the magnet will work. Now, what I had noticed with my prototype is this here, I'm not sure exactly what it is, but it must be what reduces the voltage, or it turns the voltage into heat, the reduction in voltage. Anyway, that gets pretty hot. So when it's installed, after it's all soldered up, keeping this away from the plastic is key. So we'll consider this the bottom, and then this will be the area that we just keep free. So I'm going to go ahead and solder this up and do a little testing. Alright, so I'm back, and I finished soldering this up. So the bridge rectifier is installed. Let's see if we can get the light to reflect properly to show the positive and negative here. Let's see. Oh, that's pretty close. There we go. So you can see the plus and minus. Of course, the negative matches the capacitor. The positive is on the opposite side, and the two tildes are the input. So this is power in from whatever source. Capacitor to charge and maintain and regulate the flow of power, and then this buck converter will regulate the power to power the lighting, and then of course this is the reed switch, or not the reed switch, but the Hall effect switch that the magnets will be able to turn on and off the lighting. And then what we have to do here is connect the negative to this side of the lights and the positive to this side of the buck converter, and then the power will flow when the switch is on. So I'm going to mock this up and put it on I'm thinking maybe just a flat car or open gondola or something like that, just to illustrate this. And I'll make the trucks powered, and I'll just do up an LED strip or something for around the car, and I'll just adhere it to the car. It'll be just a cheap gondola anyway, and yeah, then I'll use that as a test model to illustrate what's going on, and then I'll be able to take this, and I have a bag full of the components. So there's enough here to do 20 cars. So I have 20 capacitors, 20 bridge rectifiers, 20 Hall effect switches, and 20 buck converters. And yeah, I'll do up we'll do a clinic, and we'll do it step by step for whomever wants to do it for the Toronto Model Railroad Association. That's my club. And yeah, and of course I also have strip lighting. So I got 2 spools of it that we can cut accordingly and fix it to the cars. So yeah, I will do a mock-up shortly, and then I'll take it to the club to test it, and hopefully the capacitor will level out any flickering from the LEDs due to, you know, crappy dirty track and maybe bad situation over switches and stuff like that. So yeah, about just a little over 2 inches. So hopefully that'll work. Thanks for watching.